All systems are nominal. Initialize Genesis sequence.
Well, welcome back. I have a feeling we've seen each other before, so thank you for sticking it out for the evening sessions where I want to talk a little bit about what it means to be an architect. Now, architects are sort of funny animals, right? So some people who believe architects are sort of the most important people, make all the decisions, usually a little bit more gray hair, the wisest folks. And then likewise, there's other folks that say, hey, it's just people up in the ivory tower drawing pictures and not adding much value. And the other part is, some people have architects on their business card, but many of them I wouldn't consider good architects, and vice versa. Some of the best architects I've met are not actually called architect by title. So we should think about this, okay, what is with this architect thing? Because we already talk about what is architecture, and there's many different versions of what architecture is, and sort of the easy answer is architects are the ones doing architecture, but then we're none the wiser if that is hard to define. So my pitch today is that it is not what's on your business card, it's not what your title is, it's not what you sort of think you is, but architect is really much more of a state of mind. It's a sort of way of thinking or a way of looking at things. And to sort of undo this whole notion of the architects being the ones who somehow smarter, wiser, should be making all the decisions, my opening statement is really that the architects are not meant to be the smartest people in the room, right? How can it be that one person is sort of smarter than all the others, even if they're a little bit more removed from the projects to make matters worse, right? And then they're somehow supposed to make all the decisions, right? Seems a rather silly idea. But architects can do one thing, and that is make everybody else a little bit smarter, explore more options, expand the solution space, improve decision discipline, help people see things that they maybe didn't see before, help them not fall into the same pitfalls that other people have fallen into. So that way, I think architects actually add more value because they scale, they contribute to the team as a whole, and end up being an IQ booster for the entire team. And what I want to share a little bit about today is, well, how do you do this? How do you become an IQ booster for your teams and make everyone a little bit smarter? And I go through a list of ways that I think this can be done. I don't claim it's like a comprehensive, precise list, but these are things that I've seen work throughout my career. So consider it a toolbox, a set of ideas, right? Give it a try. It may work for you, and you might and likely will find new ones, and that would be fantastic. So the first one that architects do, or the first way architects make everybody else smarter, is by connecting levels. And an easy way to look at this is to ask the question, now, who is the most valuable architect? So I worked for a large insurance company some years ago, and I had the great title of chief architect, right? So it's like, oh, that must be the most important architect, right? It's almost like the guy in the Matrix, right? It's like the chief architect. On the other hand, if that chief architect doesn't do much but just draw pictures which have little connection to reality, they don't really add a lot of value. And likewise, if you're a fantastic developer and you write the most amazing implementation of a certain algorithm, but it's actually not connecting what the business needs, right, then in the end, you also have very little impact. So my point of view is that it's not really which level you're operating at, but it's much more about how many different levels can you span. Because you will find many folks who are good at a certain level, and that's great, but being able to connect through these different levels, making sure your technology choices, your implementations, your IT strategy, all those kind of things relate back to the business strategy, being able to share trade-offs and decisions with business people or executives, right? The folks who never quite understand what we do, right? We quite honestly also don't make it quite easy for them to understand because we use funny words and languages. Making this connection is extremely important and valuable. And what I find is then also there aren't so many people around who can do this, so immediately this sets you apart. My experience there is, right, if you're able to talk and make sense across the different levels, the audience will actually be quite appreciative. They tend to say like, oh, finally somebody who makes sense and understands what's going on in the engine room, but they're easy to talk to and they don't dumb things down, right? Because, you know, up at the leadership level, you have some of the smartest people in the organization when you talk to executives. So the worst thing you can do is dumb things down, but you need to translate them in a way that is relatable to them and they can understand the decisions and the trade-offs that we're making, because those decisions and trade-offs might define the future success of the business, right? On the one hand, that is great. That means we as developers, we're not sitting in the basement somewhere doing random things, right? What we do has a direct impact on the business, but it also gives us a lot of responsibility and accountability, right? We gotta make sure that we actually do things that go into the right direction, that it links to the business strategy and supports the business. So the reason this connection is so important is because organizations are usually layered, right? There's different layers of management, different kind of specializations, and the problem that leads to is that upper management lives in a happy illusion, right? They heard you're using Kubernetes and blockchain and LLMs, so IT must be doing a fantastically good job, and vice versa, you know. Folks who write in code enjoy the freedom because, let's be honest, you know, the management chain doesn't know so exactly what you do, so you have a lot of choice. Now, how is this possible? Well, there's this isolation layer in middle management that forms this loosely coupled architecture. In this case, it's not a good thing this is loosely coupled, because if the two things are disconnected, right, you have the point where the things we do don't add value and the strategy we don't actually understand or even know, so both directions, this doesn't work. So the idea of architects connecting levels is very much fix this problem. And as architects, we like models. So I want to explain how this came about using a model. Even in the keynote, I joked a little bit about architects see more than other folks. So here are the proverbial 4 boxes and 3 lines. And some people might say, okay, how interesting can this be? Well, in reality, this can be very interesting to architects. So why do we do layering? It's one of the most fundamental patterns we use all the time, right? We have like front ends and back ends and different layers, different abstractions, right? Because it gives us a lot of benefits. Oops, there we go. Oh, my clicker here. So it gives us a lot of benefits, right? So one thing does one thing well. One box does one thing. We have separation of concerns, separation of responsibility. We have clean interfaces. We have clean dependencies. And that affords us some nice stuff like replaceability. It's easy to take one piece out if you have clean dependencies. So many benefits to be had. But architects are in the business of making trade-offs. Where there's light, there's shadow. Where there's a plus, there's also a minus. Layers can also lead to overhead, right? And we see this in technical systems. I've seen this where sort of every layer talks to the other layer with XML, and then the whole system doesn't do much except, you know, parsing XML and doing garbage collection, right? So there's certain overhead. Yeah, I've seen this real life. It was an architecture decision to require XML between all layers, right? There you go, right? So it can introduce latency. It can bring its own complexity. If you have 20 different layers, people start arguing which layer something belongs into. And the last one you know well is, so let's say you have a system where you have a front end, a back end for front end, a business logic layer, API layer, object relational mapping layer, and a persistence layer, and you want to add a field to the screen. So what do? You add the field to the front end, the back end for front end, the business logic layer, you know, the API layer, the object relational mapping layer, and the persistence layer. So you have change propagation through these layers. That is not great. So, well, classic pattern, some goods, some bads. Now, the way architects see more is the things on the left are different than the things on the right. So if you squint a little bit, sort of the ink blot kind of test, if you look very carefully, they're not out of the same mold in a way. And somebody once gave me the answer, says, oh, the left is the theory and the right is the reality. And that was a very clever way of putting it, right? It was like, hey, the left is PowerPoint and the right is sort of the runtime, how this actually comes to haunt you. So what happens is, and it was a clever way of putting it, the more sort of architectural way of saying it is, the left is largely structural. These are structural considerations, separations, interfaces, dependency. It's more static, right? And that is good, but the right-hand side is much more dynamic, operational. And that gives us a hint that the more change you have in the system, so the more the dynamic parts play a role, the things on the right-hand side start to outweigh the benefits on the left-hand side. So if you have a slow changing system, the left-hand side wins. If you have a fast changing system, the right-hand side wins. You know, it starts to drag things down. So this leads us to some interesting insights. The one thing is, organizations have so many layers because they used to benefit, and now we live in a world full of uncertainty and change. So now they're suffering from this, and they cannot easily collapse the layer. So hence the architect elevator. Second insight we're gaining is much of what I just talked about, almost everything I just mentioned, doesn't really have anything to do with a technical system or an organizational system, right? We kind of flip back and forth between the different domains. Take replaceability, right? In an organizational system, that is called outsourcing. I can take some department out and give it to somebody else. So what we learn here is that organizational systems and technical systems actually behave similarly. And that is very interesting for you guys as IT, as technology architects. You know a lot more about organizational architecture than you might realize. Give you a simple example, right? Trying to build a high throughput system, I think I joked about this in a deep dive, is when you try to build a high throughput system, the worst thing you can do is have a synchronization point, right? Because stuff waits and synchronizes, so that is a throughput killer. In organization, that is called meeting. And it's also a throughput killer, right? So it's exactly the same. And that is very helpful because in the end, you do need to understand organizations, right? If you want to do things like DevOps and agile ways of working and all these kind of things that we do, you do need this knowledge about organizations, but you're already extremely well equipped about it. And that's the idea of the architect elevator. You can't collapse the skyscraper into a bungalow, so the next best thing is you can ride the elevator. The key thing is not telling each level what they want to hear or making up different stories, but actually finding ways to connect the message across the different layers. And here's a perfect example of this. Long time ago, I blogged about this, where let's say you have a conversation between, folks in the engine room, and they like the things on the left-hand side. They say, hey, here's all the cool stuff, my sort of digital new way of building software, right? I have high levels of automation, I'm fast, I release frequently, and I have tight feedback loops, right? Like fantastic stuff, that's what we all like. Then a CIO will say, okay, that sounds really nice, but to be honest, when I talk to my boss, right, probably the CEO, the member of the board, someone, right, they have different things from me, right? They say, hey, make sure this stuff is secure, nobody wants to be in the newspaper, make sure IT runs, nobody wants to pay for IT that's not running, and if you can spend less money, that is even better. And then they could argue for a long time. So the architect elevator is about not saying different things on different levels, but showing people how they actually connect, right? So how do you get a good security posture? By doing things manually? Heck no, right? High levels of automation, make sure you have consistent patching levels. Also, never assume everything is in good order unless you actually have observability and feedback, and you do this quickly. What is the best way to get high availability at low cost? It's not by doing warm standbys, right? That's the silliest way, but you do it by having automation and feedback cycles, auto-scaling up, auto-scaling down. So the things on the left are exactly what makes the things on the right possible, and that is the architect elevator. That you show people, look, there is a connection here, this all makes sense, and you can have this conversation across many different levels in the organization. These models are very powerful, and yes, it's about connecting the dots, not telling entirely different story. So metaphors and models help you get this vertical mobility to make sense to executives, right? You're talking to very smart people, so not inviting them into the thought process is actually a very bad thing because it frustrates them. You know, you have smart people there who basically you talk mumbo jumbo, they can't really think with you, and it's underutilizing resources of your organization, right? You have some of the most accomplished people in the organization, right? And they can't think with you. That in a way is a waste. And I always remind people when you go to upper management and you say, hey, I have this fantastic idea, and you talk like, you know, Kubernetes, Helm charts, serverless, containers, and then you say, okay, $3 million, I need funding. Basically, what the other side is hearing is, trust me. Right? It's like, because they have no idea, really. And they may still trust you, but it's a very thin layer of ice that you're walking on. So give them more insight, share your trade-offs, the decisions, your thoughts, and a powerful way to do that is through metaphors, and you'll see this throughout my talks. Now, sometimes architects are made fun of for drawing pictures. I actually think drawing pictures is very important for architects, and we'll see more of this because pictures are models, they're abstractions, is the best tool you have to tackle complexity. So pictures are really good, but when you think about the kind of pictures that IT architects would draw, you know, this kind of stuff comes up. It's just like an internet search, right? What is an IT architecture diagram? It's all these boxes kind of things. Now, having comparisons between IT architects or software architects and building architects is always a slippery slope, but I think in this case we can learn something. And what we learn is that famous building architects are not drawing the blueprints. Right? There's engineers and many other people. The blueprints are very valuable, needs to be done, but there's other people doing this. The famous architects, they sketch. And the first reaction you might have is like, oh, I could have drawn this, or my 3-year-old could have drawn this, or my cat maybe could have drawn this. But the answer is no, they probably could not have, because the sketches capture the essence of what is going to be done, the ultimate form of abstraction. Like, you need to understand the context, you need to understand the purpose of the thing that you're building, you understand the site, that is the materials. There's actually a lot more in there than it might seem. Sketches are very powerful. In a way, drawing a blueprint is very mechanical, like, many people can do that. Making a good sketch is actually much harder and is the signature of a good architect. And if you're worried that this has nothing to do with reality, if I had a little bit better Photoshop skills, right, I can probably get this to match up, that what was actually built in the end actually looks very much like this. This is the Guggenheim Museum in Bilbao, Spain. So as architects, we want to be good at drawing, but with a focus on sketches, capturing the essence, not making these big tapestries, but making something that really expresses what we do. Very related to this is, I keep saying architects see more than other people, and I mean this in a positive way. I don't mean other people are not as clever. It's just like sort of a different way of looking at things, right? And part of that is seeing more dimensions. And my favorite sketch for this is this, where you have two people arguing with each other, and one person says, oh, this is obviously a circle, and the other person says, this is obviously a rectangle. And they go back and forth and back and forth. This is a little bit like I mentioned in the keynote, when one person says, hey, we need to speed up the project timeline, and the other person says, oh, but we can't compromise the quality. Right? They assume these are like two different things, and as an architect, you can say, hey, look, this is actually a cylinder. This is like 3 dimensions. You can speed up the timeline and still meet your quality bars, for example, by having automated testing, more frequent releases, having the testers more integrated with the dev team, whatever it may be. You see more dimensions in the solution space. You're not stuck on this, circle versus rectangle discussion, and that is extremely helpful. It gets people out of this rut, and I'm sure many of you have seen these kind of debates where it's like back and forth, and you can step in. You don't tell them what the answer is, but you show them that there's more dimensions, and that way they can come to a good answer. You're expanding, so that the big way of saying is you're expanding the available solution space for them so that they can come to a better solution. And that is one way you make them smarter, right? One way I do this, an example I often used to work for AWS, and my proudest achievement at AWS was that I got to give a talk at reInvent that has the word lock-in in the title. Not easy to do for a cloud vendor, right? It's their least favorite topic, so somehow I was able to sneak this in. And one way I showed that we see more dimensions when we talk about lock-in, we talk about switching cost, right? If I need to go somewhere else, how expensive is that going to be? But that is only one dimension. The other dimension is how much benefit do I actually get, right? And immediately you're having a more interesting discussion. You talk about ROI. Am I getting commensurate value for higher switching cost or not? Obviously, having high switching costs for low value makes no sense, right? The cell phone providers used to do that where you couldn't take your number to another provider, right? They were artificially locking you in even though you weren't getting much value. The regulator stepped in and we got number portability. The interesting ones on the right-hand side, accepted lock-in, right? Am I willing to accept a higher switching cost for more value? Old friend of mine, Adrian Cockcroft, many of you probably know, from Netflix and also from AWS. He had a very nice way to explain the top right quadrant. He would go to the audience and say, who here is worried about lock-in? Well, all the hands go up, of course, right? You should think about lock-in. And then he says, well, who here is married? And then everybody looks at the hand and was like, well, yeah, it kind of worked out not so bad, right? So in the end, there are benefits to long-term relationships, right? Think about it along two dimensions. So those are simple examples where suddenly you get a different kind of conversation. You get out of this FUD of like, oh, we can't be locked in, the vendor is locking us in. It's like, no, it's switching cost, it's just money, you know. Money isn't free, but there's a bank, right? We can think about it. We can think about how much value we get against it. And then it's a simple economic decision, right? There is no fuzziness here, no funniness, no FUD. Nobody goes to jail by being locked up. As an architect, you made everybody else a little bit smarter. And to take this even further, right, the dimension of switching cost itself, which is just one of the two dimensions we showed, that alone breaks down into many different dimensions, right? I wrote about this in Cloud Strategy, right? This could be, we normally think about the switching cost of switching a vendor, but switching a product also costs. Even switching a product that you built yourself is not free. So one funny example I like to cite is, I always joke that the least favorite feature at AWS was the extended version support on EKS, right? The Kubernetes, Elastic Kubernetes service, right? Why would you need extended version support? Why isn't everybody on the latest version of Kubernetes? And we charge people for it. AWS make you pay. If you want the old version, you pay extra. The answer is very simple. Switching cost. Even going from one version to another of an open source project is not free. You have other things to do. There's opportunity cost. You might need to test. You might have many of those clusters. I've seen people with 200 EKS clusters, right? So there you have it. Right? You have switching costs. You have lock-in into a specific version of an open source product. So that gives you a much different way to think about this. Doesn't mean lock-in isn't real, right? Of course, it costs money, but it gives you a different way to have this conversation. And that way, you made everybody a little bit smarter. You get out of this FUD factor. Now, here comes an interesting one. Architects sell options. And this came out of a conversation I just had with top-level executives, people who reported to the CEO of one of the largest global insurance companies, that very fancy offices, and they asked somebody, what do architects do? And people came with this usual, like the components and relationships and decisions, and this was the former head of asset management, right, insurance, and I could see his eyes glaze over, and sort of in the spur of the moment I said, we sell options. And immediately the person like, oh, what do you mean? Because that is something that they can relate to, right? They're financial people, so they know options trading very well. So what I explained, and I hinted at this in the keynote a tiny bit, is as architects, we can give you options. Options are things that you can do, but you don't have to. Options defer decisions into the future. So for example, as an architect, I can give you the option to add or remove hardware capacity later, right? And by that, I defer the capacity decision from right now, where I would have to make a wild guess. I can defer that decision into the future. And that is valuable, because in the future I am smarter. It becomes much easier to make a decision in the future because I'm no longer guessing. The future is right there. So deferring decisions has value, and I can do this with options. So classic example that I hinted about, how do I get the option to allow people to use different languages? The answer for us is very easy: standard interfaces, standard APIs. So what I have done here, I have given up some options, right? I can't have 15 different protocols, right? I locked this down. I gave up one option. I harmonized this thing, but in return, I gained other options. And that's an interesting architecture maneuver, right? I give up some things, I gain other things in return. So I should think about, when is this valuable? Am I net gaining, or am I net losing? Very interesting discussion, right? This is about architecture decisions, right? This is selling, and I call this options trading. Now, I hinted at metaphors, right? When you translate something into people's domain, if you bring technical decisions into their domain, they can immediately think along with you. And in this case, my conversation, it went immediately here. Now, to financial people, this is horribly obvious. And this gives you a little bit of appreciation how complex our domain is, right? Because when we talk technical stuff to business executives, it looks exactly what I'm doing to you right now. It's like, isn't this utterly obvious? And many of you might think, probably not so much. For financial people, it is, because it's the Black-Scholes formula of options pricing. So when I told this gentleman, head of asset management, that architects sell option, he immediately came to the conclusion that he said, oh, I like that metaphor, and I know that the higher the level of volatility, the higher the level of uncertainty, the more valuable the option becomes. That to them was perfectly normal. They know this stuff. So they're thinking along with you and for you, and that's extremely powerful. It's easy to understand plausibility. Let's stay with the scalability example, right? If I give you the option to add capacity, that option is more valuable if the load is unknown, right? If I build something for 10 users, I don't need the option to add capacity or remove capacity in the future, because that doesn't happen. If I'm building a mobile app or some e-commerce or Black Fridays or whatever, right, something that is very volatile, that option is valuable. Right? And that holds in this metaphor. It's a little sigma square there, right? They got a Nobel Prize in economics for this. Sigma square is the volatility. So with increasing volatility, the value of options goes up. And here comes the kicker. If architecture is selling options, that also means the value of architecture is going up. And we do live in a very fast-moving, very uncertain world. So the value of architecture goes up. Two more quick comments here. The one thing is, remember I said architects sell options. I didn't say we donate options, right? We say it creates options. It should be sell options. We're not giving them away. How do people pay for options? And Brian actually this morning, the keyword again, had the best word for it. We largely pay for it with complexity. And that is the real cost, right? Money can be had. There's a bank where you can get a loan. There's no place to deposit extra complexity. You can't get rid of it unless you invest more of it. So let's say this adding capacity later, right? I need scale out. I need a load balancer. I need automation, right? I will have more moving parts to get the option to add hardware at will at any time, right? It's, you know, the cloud makes this easier, but fundamentally it's more complex. So you pay with complexity, and that's how you make this trade-off, right? Is it worth getting this option? Volatility is high, probably yes. I pay with complexity. Does it not have to change? You know, probably I don't buy this option. Second part that this leads to, very interestingly, so what I just basically told you is that the higher level, the level of uncertainty, the higher the level of volatility, the more valuable architecture becomes. And we have another word starting with A that we use a lot, and that is the word agile. And often they're seen as at opposites of each other, right? Architects are portrayed as these like rigid bean counter kind of people with all the rules and making the boxes all exactly square. And the agile people a little bit more sort of loosey-goosey, right? Living in the day, kind of. That's kind of the kind of weird image we have, and they seem to be opposed to one another, right? You will have some people who come to you as an architect, and they will say, hey, I love what you're doing as an architect. This is really valuable, but you know, I am agile, so see you later, right? I don't need you. Now, here comes the kicker. Why are people doing agile methods? If they knew everything and nothing ever changes, you don't need to be very agile. You write it all down, you code it out, you deploy it once, you're done. So the reason we do agile is because we have volatility, we have uncertainty. And like, hold on, this is exactly why we have architecture. So both agility and architecture thrive in environments that deal with high levels of volatility, high levels of change, and high levels of uncertainty. So they actually thrive both in the same environment. There's absolutely no contradiction here. So that nice thing is I sometimes say architecture is the engine or the gas pedal, my car metaphors, right? And agile is the steering wheel, right? The one makes sure you keep moving and the other one makes sure you're moving in the right direction, and both are needed to actually get to the destination. So yes, a little bit of love for architecture and agility. One way that architects tackle complexity. So complexity is the biggest enemy in this thing. And Brian, you know, I could not have had a better segue than from Brian in the keynote. Complexity is the problem. So how do you tackle this? One way you do this is by zooming in and zooming out, right? Seeing things at different layers of abstraction. And our world is not like sort of like a camera zoom kind of thing. It's much more like these Mandelbrot sets, right? If you look at things from different layers, you see very different things. One of my favorite examples is, you know, there was this study of how much you can get paid as an architect if you have a certain cloud certification, right? It was a different cloud vendors, professional, something rather certification. You can make this much money. Somebody who's a developer will decide, oh, this cloud is really good because I can get certified in it and I get a higher salary. The CIO will look at this and say, hold on, this cloud doesn't have enough qualified people, so I won't find folks to work on it. And if I find them, they're very expensive. So probably this is not my favorite cloud. So two people at two different levels come to the opposite conclusion from the same piece of data. And that's exactly this. They see different things at different levels, and understanding this, right? This is the elevator in action. Understanding this makes you much more effective in these kind of communications because you can anticipate how other people at other layers think. But it's not just about the organizational layers, it's also the system. As most applications we build today, they're distributed, right? They're like either distributed in themselves, or they call out other APIs, or they're SaaS services, or they call cloud services, right? It's extremely rare you will build anything that lives in isolation. Yet most of the time when we build systems, we look at the boxes and what's inside the boxes. We have a lot of tools and methods that deal with the boxes. But the lines are at least equally important. And the more pieces you have, the lines become more important than the boxes. So look at these two very elaborate systems built out of the components A, B, C, and D. And I assure you the right-hand side has the same components A, B, C, and D. There's no trick here, but it has different lines. So would you think that these two systems have different characteristics? That is a trick question because the answer is obviously yes, right? The left is layering we already had, right? And this sounds a little bit like, you know, I'm belaboring the most simple architecture thoughts, but it leads to interesting insights. The left is layering, so it has all the characteristics of layering. Easy to replace a component, but a little bit higher latency from A to D, and if B goes down, A no longer talks to D. The right-hand side is exactly the opposite. Shorter path, less latency, more resilience. If B goes out, A still talks to D, but harder to replace because more dependencies. So, long story short, they have exactly the opposite characteristics built from the same pieces. So how you put things together matters. You need to zoom out and look at the system as a whole. I often say architects are like chefs, right? Having good ingredients, right? Buying high quality A, B, C, and D's is good, but the meal comes from putting it together. And that's what we as architects do. So we need to see end to end. A lot of folks are optimizing locally, and that makes sense, right? That's like their realm of responsibility. That's what they control. That's probably what they get rewarded by. They make sure they build a really nice A and somebody else builds a really nice B. They're looking at one thing at a time. So you need to balance this off as an architect by looking at the system end to end and make sure we are not stuck in a local optimum, but actually get much closer to a global optimum. Because what we learn here is the sum of local optima is rarely or never a global optimum. You need to have both viewpoints. You look at one thing at a time, but you need to zoom out and look at the gestalt, understand the system as a whole. And this could be the technical system or even including the organizational system, right? You need to understand the whole thing because that really defines the characteristics, right? That defines how this system works. If you want an example out of operations, right, it's the classic one, all lights are green, nothing is working, right? Each box is perfectly fine, but the system as a whole is not functioning, and anybody who spent time in operations has been in that situation. Everybody says, hey, my database is fine, my server is fine, the front is fine, everything is fine, but somehow is not working, so we need to zoom out and understand that decision as a whole. So I want to get back to the pictures a little bit. I hinted that sketches are so powerful because they are models. Models are one of the best tools that architects have. We have the metaphors and we have the models, and they're actually closely related. So here are two models of our solar system. And this is sort of the days of Copernicus. It was like the 1300s or 1400s. I need to actually look it up, where basically the church had the idea that, hey, the earth must be in the center of everything because that's where we are, right? You know, a little bit self-centric. It's called a geocentric officially, right? They said, hey, we must be in the center of things. And if you use that model, the planets move in relatively odd paths, including some surprisingly sharp turns. If you use a different model, you know, the heliocentric model, hey, the sun is actually in the center of our solar system, suddenly everything makes sense. So again, that leads to some very interesting insights. A, both models are wrong, right? The sun isn't this little yellow dot that's on there, and the planets don't move actually in circles, right? It's much more complex. So it's not accurate in a way, but expresses the essence of what we're after. It helps us reason about what we need to reason about. That's why we have the model. We don't draw a one-to-one scale model of our solar system, right? So in the essence, it is wrong. The other thing is that what you realize, once you have the right model, the decision is sort of obvious, like it all makes sense. It seems horribly simple. Now that is a good lesson for architects. I say once you choose the right model to think about your system, the answer is obvious. And this could seem a little bit anticlimactic. It's like, oh, it's so obvious. You feel a little bit unaccomplished almost, right? Because it should be harder. But that means you found a really good model to think about your system because of the answer just pops out. And that is perfect, right? There's always smart people who've made nice quotes about this, right? All models are wrong. They're not reality, right? Last time I went on a hike, I did not see the contour lines on the mountain, right? And the highways are not painted red and orange. But even, you know, George Box, you know, if you read the second part of the quote he said it's the simple and evocative models. Those are the most helpful ones, not the tapestries, right? The more you can abstract away, the more you're getting out of the model. You're not trying to draw reality, you're trying to make a better decision. So the more abstraction you can have, the simpler model you can use, the better you're gonna be at making that decision. So these tapestries look nice, but they're not actually the most useful models because they're not really abstracting much. So here are 4 models of a system that we know all fairly well. That's called planet Earth. Now the question is, which one of these models is the best model? Now that is once again a trick question, because the best model depends on the question you're trying to answer. So the topographical map on the left, top left, that helps you decide quite a few things. You want to go for a hike, but you don't want to climb steep hills. You want to build a ski resort, so you do like steep hills. You're building a house and you don't want it to be in the flood zone. Very good. You're building a dam. You're trying to see what actually gets flooded and where to put the dam. Perfect map, right? So the model can answer many, many questions. The other models answer different questions. What's the fastest way to get from A to B. I always joke about the top right one that is meant to explain the US elections, but I'm not sure, even models have their limitations, right? It's a political map, right? It's supposed to help you understand things like elections. And the bottom right, used to work for Amazon. People who build distribution and fulfillment centers, they find these population density maps very, very helpful in combination with transport maps. So the best model depends on the question that you're looking to answer, right? We're not in the modern art museum. We're not drawing these pictures because they look, for fun. We draw pictures so we can make better decisions and answer questions. So next time somebody says, show me your architecture, a very valid counter question is, well, what question do you have in mind? What are you looking to answer? Because the model, right, the architecture, nobody sees the real architecture. They're going to see a depiction of the architecture, right? They're going to see a model of this architecture. And which model you should show them really depends on the question you have. There's not one universal, there's not like a show me the architecture. It's like, no, what are you looking for? What are you trying to decide? What are you trying to understand? And based on that, you can select the best model. So the model isn't good or bad. It is suitable to answer the question you have. It's suitable to help you make a better decision. So a couple of insights, right? These tapestries look impressive, but they're actually the least useful model. The only question they usually answer is, why does everything take so long and why is it so expensive? But people kind of already knew that, so that is not adding a whole lot, right? The other one I want to highlight is sometimes people feel when I have a lot of uncertainty, I have a lot of moving parts, a lot of variables, I don't know how many users I'm going to have, and I don't know what the business is going to do. People feel like a model cannot work because they feel like I cannot capture this thing. It's just like too fluid. That is actually when models add the most value, because they force you to make assumptions. You go based on scenarios. We have a low, medium, high user scenario. You can share this with executives. Say, hey, I evaluated this along 3 scenarios. Here's my architecture for these 3, right? Which one do you want? Do you think this is a reasonable trade-off? So if you have more uncertainty, the model actually helps you better because it gets you out of this rut of like, I don't know, right? It gets you into rational thinking. So that's when models really shine, is when you have high levels of uncertainty, because it forces you to make assumption and put some stakes in the ground. And last, right, a good model depends on the question you have or decision you need to make. We're not producing abstract art. So now we talked about dimensions, right? It's all very visual. We like pictures, models, dimensions. The other one is shades of gray, right? Our processors are largely binary, right? And our software maybe is binary. The rest of this world is not binary, including most of the architecture we are talking with. Everything has shades of gray. So I've gone public by saying you can easily identify the worst architects by the people who always speak in absolutes. Oh, this must be like this. Everything must be in a container. Everything must be like this. It can never be like that, right? They go on these extremes. That is actually the signature of a not so good architect. And one thing I learned on social media, strong opinions always get more likes, so that is pre-programmed. Still, nevertheless, this was sort of one of my most successful posts, right? It is not about spewing out absolutes. It's about understanding trade-offs. So I come back to this lock-in story because I wrote quite a bit about it. In the end, the switching cost and lock-in is also a continuum. There's an amount of money that you can invest to reduce the switching cost, right? That has a certain cost. And in return, the switching cost goes down. And what you're doing is you're minimizing the sum of those two, right? What you invest right now and the potential switching cost that you would have multiplied by the likelihood that you actually switch. So basically the way I explain this to people is, let's say that moving to another cloud, just for argument's sake, would cost you €1 million, right? Because there's a lot of effort. It costs you $1 million, right? Then you say, okay, I have a 5% chance that this will happen in the foreseeable time horizon. I say 5 years or whatever, 8 years, whatever sort of the lifespan of the stuff is that you build 5% chance on it. So that means you carry a €50,000 liability. Again, translating things into money is kind of magical because it takes all the FUD out. Now it's €50,000, right? It's not like 10 billion, and then you say, hey, can I invest money to bring this down from 50,000 to 10,000 by maybe using managed open source, being smart about how I package my code, like, things that I can do. And yeah, I can do that, doesn't cost me much, and boom, this goes down. Great decision. So it's a spectrum. Like lock-in is not a switch. It's not like, same as coupling. It's not like things are like coupled and uncoupled or locked in or unlocked, right? These are all spectrum. These are shades of gray. And your job as an architect is, you won't calculate the absolute mathematical minimum, but you have sort of this feeling that it's unlikely that the best decision is on the far ends. It's rarely on the extrema. So you kind of sort of check where you are. Basically, on the right-hand side of this picture is being over-insured, right? You paid way too much money for a case that is unlikely to happen. And the left-hand side is being naive, right? It's like, oh, whatever, right? So both of them are not good. So it's shades of gray. It's always a spectrum, and often the optimum answer is in the middle. If you follow this, you can even do more fun things, right? The money you're investing right now is more expensive than the return you're getting in the future because discounting rates, inflation. So you can set a discount rate, right? If this costs me $100,000 now, that is more expensive than getting $100,000 back in the future. If your startup company costing you $100,000 right now may put you out of business. So you can take these models much, much deeper, and you can see how powerful this is to get out of this FUD. Now we can have a much deeper and much more rational discussion about this. Now that is one way as architects you make people smarter. So quick recap, right? What have we seen? Organizations are layered because it used to work well for them, right? It's easy to say, oh, they were stupid, they do things badly, it's too much overhead. No, they're quite successful, right? They got there. They're sometimes 150 years old or older, like many banks, insurance company. So it used to work for them, but now it's becoming a hindrance. It's not because they're dumb or anything, it's just the environment has changed. So what do? We help them by connect the different levels. We like pictures, but not the blueprints. We like sketches because they give better abstraction, more opinion, like a better viewpoint that you as an architect bring. Getting people out of this A versus B by showing more dimensions, very powerful, right? You don't tell them what to do, right? It's not about you answering all the questions, but you help them come to a better answer. Options, good for many ways. You defer decisions. That is great to do as an architect because in the future, you're always smarter. But it's also at the same time a useful metaphor, especially for folks in the financial industry. And it led us to the insight that architecture and agile are not at all opposites. We talked about zooming in and zooming out. And the model, basically, we talked about all around. Everything I showed is a model. There is no universally best model. There is no universally best architecture picture. It really depends on what question you're looking to answer, what decision you're looking to make. And yes, some things in our field are binary, but it's only the very low-level things. Nothing that architecture deals with is binary. It's always a spectrum, and often it's a spectrum across different dimensions. And that's what makes architecture fun, right? It makes it challenging, but it also means, right, we add a lot of value. We do an interesting job because we see things in a slightly different way, and by doing that, we make everybody else a little bit smarter. So again, if you like this kind of stuff, this kind of way of thinking, this is largely what the Architect Elevator is about. And what I have done is really use that way of thinking when I wrote my other books. So basically, I applied this way of architecture thinking to different domains, right, like cloud, platforms. I'm probably going to write something about API. And that, again, has helped me as an architect sort of have the meta-level discussion, right? Like, does it mean to think like an architect? But at the same time, I can map that to the specific domains and the specific problems. And with that, I hope you got some inspiration out of, I didn't really tell you what an architect is, and that wasn't the purpose of the talk, but I hopefully conveyed to you that it's a very interesting role to play, and the key thing you can do is you can be an IQ amplifier, you can make everybody else a little bit smarter, and I find that to be a very fulfilling and important role. So please be happy architects. Thank you.
All systems are nominal. Initialize Genesis sequence.